Yeah, the homework in mastering is not all. I mean, it can be a little overwhelming sometimes. All right, so let's do carbonate. So that is CO3 2 minus. All right, so the first thing we want to do is calculate up how many valence electrons does it have, plus whatever its charge is. So if carbon is in group 4A, how many valence electrons does carbon have? 4. All right, we just have one of them, so it's just, times 1, so we just leave it as 4. And oxygen is in group 6A, so how many does it have? 6, yep. So that's going to be 6 times 3, because we have 3 oxygen, plus the charge. If you look here, the charge is 2 minus. So I'm not going to put in plus -2. I'm just going to put in 2 because it's added 2 electrons onto it. So plus 2. And that's going to give us our total valence. If it was 2 plus, then I would subtract 2 from it because 2 of the electrons would have been removed. All right, so it's 18, 24. Yeah, some of you guys are faster with math than me, for sure. Okay. And I keep forgetting you can't see what I'm typing until I hit enter. All right. So that's the valence. So which one do you think goes in the middle, the carbon or the oxygen? Carbon. There are 2 ways to tell. One is that normally they write the one that goes in the middle first. Not always, but usually. And it's the one that's less electronegative, so long as we're not talking about hydrogen, because hydrogen always has to be on the outside. All right, so he showed a skeletal structure a minute ago that didn't have any lines. Skeletal structures have got to have lines. So just keep that in mind. This is a skeletal structure, right? It's just the carbon connected to everything. And then, we're good. So before I forget, because it's easy to forget, I'm going to go ahead and put brackets around it and put the charge on the outside. Anytime you have something that's polyatomic like this and has a charge, you want to put the charge on the outside of the bracket. All right. So we've used 2, 4, 6. So then we have, oh, crud. Gosh, is there not an undo button? Let me see. No, there's not. Anyway. I know, it's so sad. Okay, so we had 24. We used 6. We have 18 left. I'll just draw it again. Give me a second. I'm using my mouse to draw today, so it's a little slow. Aw, bless you guys. That's so sweet. Okay. So we're going to take the extra 18 that we've got and put it on the outside. All right, let's see. And they're not really supposed to be little circles, but it's easier to do on my mouse. They're supposed to be filled in dots, but so I just don't want you to think that since I'm drawing circles, you have to draw circles. There should actually be dots. Okay, so now we've used 18. So that leaves 0, right? If at this point we had extras, they would go on the central atom, but we don't have any extras. So now we check to see if carbon has an octet. So does carbon have an octet? No. And so an octet means, does carbon have access to 8 electrons? The answer there is no. It only has access to 6 because there's 2 in each one of those lines, right? So that means that we have to borrow some electrons and make a double bond, right? So it doesn't matter where you choose because there are 3 equal places. And that's how I know immediately that there's going to be resonance, because they're identical. So I'm just going to take these and put them down here. All right. So if I could figure out how to use the eraser, just erase one thing at a time, I would erase those dots and the arrow. So just pretend they're gone. There's not all that scribbly stuff. Okay, so there's that one. And then we put the charge, and then that one resonance structure is done. You can turn the pencil white. Oh, you know what? I never thought of that. How did I never think of that? I know I've seen you guys do it before, but like I didn't know how you were doing it. I think I need to make my pencil a little bit wider. See if I can do that. Nah, I can't figure it out right now. Anyway, you get the idea. Okay. So to draw resonance, the next thing you do, yes, one single bond is worth 2. And a double bond is worth 4. So every line is worth 2 electrons. All right. So then we draw a double-headed arrow, and then we draw the same thing. Oops. All right. But this time I'm going to move the double bond somewhere else. And that's what makes it resonance. And then I put in the lone pairs, put them back, you know. And I'm not going to put 4 around, I'm not going to put 6 around this one, because I borrowed 2 of them and they're in that double bond. So oxygen's got 8 around it, so it's good. All right. And then, you draw the double-headed arrow. And the more resonance structures you have, it actually becomes more stable as you have more resonance structures. So if I had something that had 2 resonance structures compared to something that had 5, the thing with 5 resonance structures is more stable. All right, and then, you add in the dots. And so forth. I'm not going to add in all the dots this time because you get the idea. Does anybody need me to put the dots in there so you see how it works? Probably not. Okay, so these 3 are actually just like, they contribute basically a third to the actual picture. Yeah, you'd have to draw all 3. The reason is for a couple of things. So only 1 oxygen is octet. Actually, they're all 4 octet. So let me change this color. Okay, so let's look at this oxygen. So that's 2, 4, 6, 8. So that oxygen's got an octet. And this is 4, because it's a double bond, 6, and 8. So all of the oxygens are octetted there. They look a little funny once you put the double bond in there. They don't look satisfied anymore, but they are. All right, and then the actual structure, a lot of times, and of course you got to put the thing here. A lot of times you'll see this. We're in a room. And then O. And then you see these dotted lines. This is called a hybrid structure. So the hybrid structure is just saying there is resonance in all the places that I have dots. So instead of there being 2 single bonds and 1 double bond, you have a 1 and a third bond on each one of those, because you have 3 of these and 1 is doubled. So you take this doubled one and you split it up equally among all the other ones. So let's say I had 4 brownies and 3 children. It'd be the same kind of division, assuming they're not greedy. So each child would get a whole brownie, and then that 4th brownie would have to be broken up. But if you were to draw a structure that had bonds like this, those would look nuts. So instead, they do the hybrid structure down here, or they'll do the resonance structures. Resonance structures are nice because it's really easy to tell what the bond is actually like, because there are 3 of them, so that would be 1 1/3. If there were only 2 resonance structures, that'd be 1 1/2. If there were 4, it'd be 1 1/4, right? So it's just taking the extra one and dividing it up with the other ones. All right, I think we got like 3 minutes left. Any questions on resonance? No? Okay. So did you guys see that you had 2 attempts this morning on the quiz? Good. Okay. That was because it gets so many people that have no lockdown. That's actually an accident. There's supposed to be lockdown on there, but I'm going to ignore that. So the extra attempt was because lockdown is such a pain in the butt. Sometimes people get on there, they take their quiz, and then it won't let them save. And it's not just that it won't let them save, because I can go in there and submit this quiz for them, but it doesn't even show any answers when I go in there to submit the quiz for them. You have a blank quiz, right? So if that happens, I just want you to be able to go in there and just do it again, you know? So that'll save a little bit of trouble. That's really good, Arib. I'm glad to hear that. So, oh, cool. Martin, neither. Awesome. Cool. All right. So that's all I've got for today. Yeah, you'll still have lockdown. Sorry. Today was like, I don't know, a really great gift to you that I didn't mean to give, but I'm glad you have it. So